Do you want to get an A+ in Cambridge IGCSE Physics? Make the smart choice of subscribing to Super Easy Physics and Mathematics. For sure you will benefit from Mr. Matthew's wealth of experience of preparing students to get an A+ in physics.
A semi-circular transparent plastic block. This is a transparent plastic block. A ray of light is incident normally. A ray of light is incident normally on the edge of the block. The refractive index of the block is 1.5. Calculate the critical angle. So at critical angle, so when incident, so draw a normal. So you have at critical angle, the reflected ray will be on the interface between air and the glass block. Then this angle, when the refracted angle is 90 degrees, this angle of incident is called the critical angle. So how do we get the critical angle? Critical angle is equal to the arc sine of the reciprocal of the refractive index. So substitute, that brings the critical angle to 41.8 degrees. So now the critical angle is 41.8, but let's measure this angle of incident to see if it is total internal reflection will take place if the angle of incident is higher than critical angle, but total internal reflection will not take place if the angle of incident is less than the critical angle. So they say draw the path of the ray in the block after the ray emerges from the block. After the ray emerges from the block. After the ray emerges from the block. So let's see. If you look at this, so let's see from here, what is the angle of incident? Angle of incident is what? 66 degrees. Approximately 66 degrees. So you measure from 90. So you measure from 90, 66 degrees, which is higher than the critical angle. So the ray will not pass through this part. It's going to be total internal reflection. So it will reflect back into the glass block. So this direction, so we remove that. So we allow it to reflect back. And when it reflects back, it will be at the same angle because angle of incident must be equal to the angle of reflection. So take note of that. So if here is 66, here also will also be 66. So this is how the ray will emerge from the block. So you have 2 marks for that. So once the angle of incident equals to angle of reflection and you get this ray, you get your 2 marks. So this is how your diagram is supposed to be. B. Now 5.2 show the full scale diagram of a lens and an object. So this is a focal point and the object is placed less than the focal length. So it's going to produce a visual image. Okay, the image will be on the same side as the object once the object is placed at a distance less than the focal length. Now determine the focal length of the lens. What is the focal length? Just measure the distance from F to the optical center of the lens. So you put that with your ruler. That gives us about 7.2 cm. So that is the focal length of this lens. So let's mark it at this other part so that we can draw the ray diagram. So you have the F and F prime, F on the left hand side and F on the right hand side. So let's remove that. Now draw 2 rays from the object to locate the image of the object and label the image I. So a ray of light parallel to the principal axis, after being refracted by the lens, it passes through the focal point. So this ray, then the next ray is a ray that passes the top, passing through the optical center. So on the right hand side, the rays are diverging. So the only point of convergence will be on the left hand side. So what we need to do is to extend this first ray and then this second ray so that they will meet. So extend that and extend this. So they meet at this point. So this is where the image is formed. Image I is formed at this point. So for drawing this, now for getting these two rays, you have your 1 mark. For drawing this rail, you have 1 mark. For positioning your image, you have 1 mark. That is the 3 marks that are there. Alright. Fig 5.3 show a simplified diagram of an eye with ray from a distant object and the part of the ray inside the eye of a person with a short sight. Very good. Now, a short-sighted person, ray of light from distant object converge before the retina, in front of the retina. So the image is formed in front of the retina, so that's why the person does not see clearly. So the image is formed here, so some distance away from the retina. So to correct this, a short-sighted person wear concave lenses to correct the eye defect called myopia. So the distance, so let's see. So image from distant object formed before the retina. So to correct it, the person will wear a concave lens, or we call it diverging lens. So a ray of light coming from distant objects will now be converged at the retina. So this is the correction. Sound waves have compression and rarefactions. Explain what is meant by compression and rarefaction. Compression and rarefaction. So you have this. Compression is where the particles are closer. Rarefaction, compression is where the particles are closer. Rarefaction, the region where particles are closer together than normal, or where the pressure is higher than normal. That is what we call compression. The rarefaction is a region where the particles are farther apart than normal, or the pressure is lower than normal. So you have this with this animation on the left hand side. We can see light from the sun, but we cannot hear any sound from it. State the reason for this. Well, the major fact is that what sound needs material for their transmission and propagation. But in space, there is no material. Space is vacuum, it's an empty space. So that is why sound cannot be propagated through space, and that's why astronauts have to use a radio for communication. Light does not need a medium to travel through, while sound needs a medium to travel through. So, and there is no medium between sun and earth. So that's why sound cannot be, we cannot hear sound in space. Storm CC. During a thunderstorm, an observer sees the lightning almost immediately, but hear the sound of the thunder several seconds later. Two reasons for this is that light travels faster than sound. Light travels with the speed of 300 million meters per second. That is the speed of light. While the speed of sound is just 340 meters per second. Oh, wow. So the sound of the thunder is heard 9 seconds after the lightning is seen. The speed of the sound is this. Calculate the distance from the thunderstorm to the observer. So what we need to do is just the distance is what? Multiply. So once you know the velocity and you know the time, so we can get that. So distance is velocity times time. So, but let's just see. So you have a thunderstorm here. Now the person is here. So after the thunderstorm appear, after like 9 seconds, so he hears the sound. So 9 seconds later. So how far is this person from the thunderstorm? So that's what we want to do. So to do that, distance is equal to speed multiplied by time. So that gives about 3060 meters. In a lightning strike, there is a current of 30,000 amperes for 48 milliseconds. Calculate the charge that flows. So quantity of charge is equal to the current multiplied by time. So it's just the only issue you have here is this millisecond. So that means 48 divided by 1000. So substitute that. So we have 1440 coulomb of charges that will flow. So we have 8 mark. So let's different is the work done by passing charges through a component in an electric circuit. So work done per unit charge. Now state the equation that define electromotive force. Electromotive force is work done per unit charge. So where W is work done, then Q is the charge and E is the electromotive force. So E is equal to W over Q. So let's see how we can apply it. Battery is 9 volts. The battery is in a circuit. Calculate the work done by the battery when it moves a charge of 30 coulomb around a complete circuit. So we have that. We are looking at calculate work done. So make W set of formula. W is equal to EQ. So we have that. So 240 joules. That is the work done in moving a charge of 30 coulomb round. A circuit consists of a DC power supply, a lamp, and a thermistor. So draw a circuit diagram for this component. So you have the light, a lamp. This is the thermistor, a rectangle with an L, a slant L. Then the power source. So these are the. Now let's see, analyze the circuit. In the circuit you have drawn, when the temperature of the thermistor is increased. Now one thing you should know about thermistor is that their resistance reduces as temperature increases. So that is a unique resistance reduces as temperature increases. So that is the nature of a thermistor. So if resistance reduces, what was going to happen, since we are still using the same power source, current will increase. And if current increase, the potential difference across the thermistor will also increase. So resistance of a thermistor decreases when temperature increases. Then resistance of current decreases, leading to the flow of greater current in the lamp. So the brightness of the lamp is going to increase. And if brightness increases, what is going to happen? The PD across the lamp also increase, and the brightness of the lamp increases. So these are the basic factors that will happen to the circuit that we've just drawn. So we have our 9 mark. It shows a horizontal flat coil in a magnetic field. So the coil is connected to a cell. The coil rotates. So this is an electric motor. So determine the direction of movement of the coil, the section of the coil AB, this section on the left hand side near the north pole of the magnet. So where will it move? Will it move up or will it move down? So let's do our analysis. First of all, we are going to apply Fleming left-hand rule. So this is a motor effect. So note that magnetic field moves from North Pole to South Pole. That is the direction of the field. So we know F. Then the next thing, the direction of the current, because this is a positive terminal, so current flow from A to B. So we have this. So if you position your left hand so that we know two things now. We know the direction of the current, which is your first finger, your second finger. If you put them, your thumb, your first finger and your second finger mutually perpendicular, spread them out. Then allow your first finger to point from north to south, and then your current, then your thumb will go down. So thumb will go down, so the truss is going to go down. So it will go downwards. Explain how you determine the direction. Just say that the field, magnetic field, the current and the motion are mutually perpendicular. So current and magnetic field and motion are at right angle to each other. Very good. Then magnetic field move from left to right and the current from A to B, positive to negative terminal. So that is about that. Flux cutting the coil. And then at vertical, the coil overshoots and come back. So when it's at vertical, the coil approach vertical, so the turning effect decreases. Then at vertical, the turning effect is 0. Then when they pass the vertical, the turning effect reverses. So these are the things that happen at the vertical position. Now, to operate as a motor, a split ring commutator and brush are added to the part shown in this figure 8.1. Explain the effect of the split ring commutator and the brush on the action of electric motor. It's just to help it to reverse the direction of motion and to make the rotation of the coil continuous. So that is the reason. So they help to reverse the current in the coil. Then the brush ensure current is maintained and make the coil rotate continuously in the same direction. So those are the two major issues. The split ring allows current to change direction without wire getting tangled. Then it reverses the current every half turn when the coil is at right angle to the magnetic field. So these are the major operations in electric motor. Where controlled nuclear fission of uranium-235 take place. Explain what is meant by nuclear fission. Nuclear fission. Nuclear fission is the firing of a neutron at an unstable large nucleus, which makes it to split into smaller nuclei, releasing large amount of energy. So nuclear fission is what? A large nucleus dividing into a smaller nuclei. But what triggered that reaction is the bombardment with a neutron. Now, state one advantage of generating electricity using nuclear power than using wind turbine to generate electricity. One, there is continuous supply of energy and production of large amount of energy when you use nuclear power station. But in case of using wind turbine, you cannot have a guarantee of the continuous blowing of wind. The movement of the wind cannot always blow continuously, so there's no guarantee for it. Okay. Then it does not affect the weather, and it does not depend on the strength of the wind. So that is what nuclear power, the advantage of nuclear power over wind turbine. Now, what is the disadvantage of nuclear power? Nuclear power are hazardous to health. Okay, and then nuclear power, the construction is more expensive compared to wind turbine. So nuclear resources are not renewable. So it is a final source of energy because the raw material used, the uranium, can be exhausted. So, and then the construction is expensive. It has the danger of possible leakage of radiation. So, and then it produces dangerous waste and is difficult to store. An isotope of hydrogen with one proton and one neutron. So nuclear fusion occur when two nuclide of deuterium combine. An isotope of helium and a neutron are formed. So you have this. So deuterium, so you have this 2 1 2 1. So they combine together to form. So one neutron is released, and then you have this. So to form. So actually there is helium here. The helium will not decompose into what? This isotope of hydrogen. So and helium. So okay, and helium. So this is a nuclear equation for this. Question 10. The time taken for mass. So this is a new aspect of the physics that they are testing this time, which is space physics. The time for mass to orbit the sun is 690 Earth days. The average orbit radius of mass is 2.28 times 10 raised to power 8 kilometer. An Earth day is 24 hours. Calculate the average orbital speed of mass in kilometer per second. So the distance will be in kilometer. So you already have the orbital radius in kilometer. So if you want to calculate the circumference of the orbit, so using a circular orbit, so it's going to be the circumference of a circle, which is 2 pi r. So 2 pi r, so divided by the period of oscillation, and the time taken for a mass to beat the sun, which is the period, is 690 Earth days. So convert these days to seconds. So what is the formula we need? We need what? The circumference divided by the period. So 2 pi, so this radius here will be the radius of mass. So we have this. So multiply that out. So days. So now we need to calculate the speed in kilometer per second. So we need to convert day to second. So how many hour make a day? 24. So you multiply by 24. Convert hour to second. With 60 seconds, make 1 minute. 60 minutes, make 1 hour. So multiply by 60 times 60. So this is the total answer. And that gave me 224 kilometers per second. So that is the average speed of mass. Now, state the shape of the orbit of the planet. They have elliptical orbit, so they have ellipse, the shape of an ellipse. It's not a perfect, it's not circular. Galaxy is redshifted. Explain what is meant by redshift. So if you have Earth, then you have galaxy. As the galaxy is moving away from the Earth, what happened? The light that is traveling from here, we're going to experience a shift in the wavelength. Redshift is the increase in wavelength of light from distant galaxy that occur as the galaxy move away from the Earth. So you see this one, as the galaxy move away from the Earth. So there is increase in the wavelength of the light when the galaxy move away from the Earth. So from this simple animation. Now, state the quantity that the redshift of galaxy is used to calculate. It's used to calculate the velocity at which the galaxy is moving away from the Earth. So redshift is used to calculate the velocity at which, how fast is the galaxy moving away from the Earth. So with that, we come to the 7 mark on this question, and that brings us to the last question of this paper 4. Easy physics and mathematics. I know you are reviewing this question because you want to pass your physics, and then
you are a brilliant student who wants to succeed. Please subscribe so that you keep up to date, because more tutorials solving past exam questions to assist you will be uploaded.
Easy physics and mathematics. I know you are reviewing this question because you want to pass your physics, and then super easy physics is a fast way and easy way for you to learn at your own pace. Subscribe, because on this channel more video explaining past questions will be uploaded. Congratulations as you